Mathematics can help students practice and develop thinking operations such as comparison, analysis, synthesis, generalization, specialization, analogy, induction, interpretation. Comparison is the determination of similarity or difference, homogeneity or heterogeneity, the equality or unequalness of things, phenomena, perceived objects. To compare two things and phenomena, we must analyze the signs and properties between them, compare those signs and attributes with each other, and then synthesize what the two things and phenomena are similar and different. For example, for the rectangle ABC on the side, students can use a ruler to test, compare the lengths of the sides, realize that side AB is as long as side CD, side AD is as long as side BC, side AB is longer than side BC. Analysis is the process of using the mind to divide the perceived object into different parts, attributes, and components to delve into the details in each part, in order to perceive the object more deeply and fully. In mathematics teaching, analytical manipulation is often used to find out the problem, identify the problem, analyze the relationships, terms, questions, requirements and situations of the problem. For example, when learning about the characteristics of the ABCD rectangle, students need to conduct an analysis of the rectangle into edges and angles, clarifying the characteristics of the side and angle of that ABCD rectangle. Synthesis is the process of using the mind to unite into a whole. The attributes and components have been separated by analyzing and finding relationships between the parts of that whole. For example, after considering the characteristics of the angle and sides of the rectangle ABCD, students need to summarize the results. The rectangle ABCD has angles at vertices A, B, C, D that are right angles, whose side AB is as long as the side CD, the side AE as long as the side BC. Analysis and synthesis are closely related, forming an inseparable unity. The analysis is conducted in the direction of synthesis, while the synthesis is carried out according to the results of the analysis. Deep and rich analysis is an important condition for accurate and complete synthesis. On the contrary, preliminary synthesis serves as an important premise for analysis. Analytic and synthetic manipulation are the two basic operations of intellectual activity and are contained in every other intellectual manipulation. Generalization is moving from a specific problem to a new problem containing the original problem, from a set of objects to a larger set of objects containing the original set, by highlighting some of the common characteristics of the elements of the derived set. In other words, generalization is the synthesis of common properties, contacts, characteristics in order to unite various objects into one group, one type, summarizing the common characteristics intrinsically from a certain point of view. For example, the characteristics of rectangles ABCD can be generalized to the characteristics of all rectangles by dropping proper names: rectangles with 4 right angles, 2 long sides of equal length, 2 short sides of equal length. Teachers can train the ability to generalize for students in the following steps. 1 is to identify the problem to be generalized. The second is to determine the characteristics of the objects in the given problem. The third is to put the object into a class of objects according to defined attributes and relations. State the general problem. Thanks to generalization, students perceive things more deeply, more comprehensively. Specialize the study of specific cases of a general problem. Specialization is the opposite manipulation but has a strong connection with generalization. Specialization occurs when students apply generalized concepts, laws, and rules to solve specific tasks. For example, after learning the characteristics of a rectangle, students can conclude that side MN is equal to edge PQ by knowing that MNPQ is a rectangle. Analog inference, also known as analogy or analogy, is a type of inference that goes from some of the same properties of 2 objects to draw conclusions about other similar properties of those 2 objects. We need to note that the same inference can give new results that are true or not true. For example, we have a proposition: natural numbers that end in 2 are divisible by 2. Similarly, by substituting 2 by 5, we have the correct statement: natural numbers that end in 5 are divisible by 5. However, doing the same by substituting 2 with 3 will result in incorrect statements because the number 13 is not divisible by 3. Induction is a type of inference derived from specific judgments, drawing generalized judgments. Induction has many different types. If we summarize all cases, we call it complete induction. On the contrary, it is called incomplete induction. The degree of truthfulness of the inductive conclusion depends on the number and veracity of the premise judgments. For instance, from specific calculations such as 1 plus 3 equals 3 plus 1, 2 plus 6 equals 6 plus 2, 5 plus 8 equals 8 plus 5, generalizing to the commutative property of addition is to perform an incomplete induction operation. And in this case we have the correct inductive conclusion. From multiplication 2 multiplied by 5 equals 10. We write 2 divisions corresponding to 10 divided by 2 equals 5, and 10 divided by 5 equals 2. From multiplication 3 multiplied by 4 equals 12, we write 2 divisions corresponding to 12 divided by 3 equals 4, and 12 divided by 4 by 3. However, the conclusion, from a given multiplication, we always write 2 corresponding divisions, is incorrect. We cannot write which division corresponds to multiplication 0 multiplied by 0 by 0. Deductive inference, or deduction, is a type of inference derived from premises that are generalized judgments, whose conclusions are inevitably drawn, i.e., all logical inferences. To ensure the correctness of the conclusion, the inference must comply with the rules of inference such as applying specialization operations. If it is true for the whole, then it is certainly true for the part. Applying the law of antimiddle, selection rules, modus ponens rules, modus tollens rules, bridging. rules, syllogism rules, counterargument rules. For primary school students, the General Education Program in Mathematics 2018 sets requirements for mathematical thinking and reasoning ability with increasing levels as follows. Level 1. Students can perform thinking manipulations at a simple level. In particular, students observe and look for similarities and differences in familiar situations, describe the results of the observation. Level 2. Students state evidence, arguments, and logical arguments before concluding. Level 3. Students raise and answer questions when reasoning and solving problems, initially point out well-founded, reasoned evidence and arguments before concluding.